Welcome to the trig ratios formative review. So we're going to do some problems that are similar to ones on the formative to help you prepare. And when you're done watching this, you can go ahead and take the formative. So we want to find sine A, cos A, and tangent A. So A is our angle of reference. Let's label that. And then let's label the sides relative to our angle of reference. Right? So across the triangle from angle A is the opposite side. Next to the angle, but not the hypotenuse, is the adjacent side. And actually, I'm just going to abbreviate ADJ and OPP. OPP for opposite, ADJ for adjacent. And then, of course, across from the right angle is the hypotenuse. All right, so now let's write down which sides each of the trig ratios uses, and then we'll write down the ratio. So sine, remember, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So that means the sine ratio for angle A is 24 over 25, opposite over hypotenuse. The cosine ratio for angle A is adjacent, which is 7, over hypotenuse, which is 25. And the tangent ratio for angle A is the opposite side, which is 24, over the adjacent side, which is 7. If these values could be reduced, we'd reduce. If there was a radical in the denominator, we'd rationalize. But these values can't be reduced, and there are no radicals, so we are done finding the sine, cosine, and tangent ratios for angle A. And that's all that there really is to identifying the ratios, is identify whether the side is an opposite side, an adjacent side, or the hypotenuse relative to the angle of reference. And then for sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is the opposite side over the adjacent side. And then reduce or rationalize if possible. But that's it. We're done with this one. Let's do another problem. All right, so now we're going to find the sine, cosine, and tangent ratios from angle B's perspective. So again, first step, mark the angle of reference. Second step, label your sides. On the other side of the triangle is the opposite side. Let me move that over a little bit. It's a little cramped there. Oops, we're losing angle. There we go. We almost lost B. Because that is a little sloppy. That looks like APP instead of OPP for opposite. 15 is next to the angle. That's the adjacent side, and of course the hypotenuse is always opposite the right angle. All right, so now remember sine. The sine ratio for an angle is opposite over hypotenuse. The cosine ratio for an angle is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. So that means the sine ratio for angle B is 8 over 17. The cosine ratio for angle B is 15 over 17. And the tangent ratio for angle B is 8 over 15. Right? You just have to identify opposite, adjacent, hypotenuse, and then use the correct sides for whichever trig ratio you're looking for. These cannot be reduced, and there's no radicals, so we're done with another problem. In this problem, we're going to write the sine, cosine, and tangent ratios given without values. Right? So we just have our sides labeled relative to the angle. Remember that the sides are named with lowercase letters and they're named using the same letter as the angle opposite. So side M is opposite angle M, side N is opposite angle N, and side K is opposite angle K. Right, and our angle of reference is angle K. Right, our angle of reference, by the way, will always be one of the acute angles. Right, so the side opposite angle K is, of course, side K. The side that's next to angle K is side M, that's the adjacent side, and of course the hypotenuse is always opposite the right angle. Right, so we want to write the sine, and as a reminder, sine is, I think I need a little bit more space. I'm going to write a little bit smaller. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that means the sine ratio for angle K is K over N. The cosine ratio for angle K, so adjacent side is M, the hypotenuse is N. And then the tangent ratio for angle K is the opposite side, that's K, and the adjacent side is M. And there we go. Right, so really you just have to be able to identify your sides relative to an angle of reference. Right? All right, so now we have two triangles, and we're going to identify the sine, cosine, and tangent ratios in both triangles and see what we see. And by the way, these are all similar to the problems that you're going to see on the formative. So A is our angle of reference. Right? So the sine ratio for, and let's not forget to label our sides. So relative to angle A, 4 is the opposite side, 3 is the adjacent side, and of course the hypotenuse is always opposite the right angle. So sine A is going to be 4 over 5. Cosine A is 3 over 5. Right? Because sine, right, is opposite over hypotenuse. Right? So 4 over 5. Cosine is adjacent over hypotenuse, so the adjacent side is 3. Hypotenuse is 5, so that's 3 over 5. I want to just make sure that you remember where the sides are coming from. And tangent uses opposite over adjacent, so that's going to be 4 over 3. The opposite side over the adjacent side. Let's do the same thing with the other triangle. Right, there's our angle of reference. Opposite angle A is the side marked with an 8. 6 is adjacent. It's next to angle A. And oops, somewhere the right angle sort of disappeared. But that's where it goes. And opposite the right angle is 10, and that is the hypotenuse. So the sine uses opposite over hypotenuse. So that would be 8 over 10. But we see that those values could be reduced. They're both divisible by 2. So if we divide 8 and 10 by 2, we have 4/5. Cosine is adjacent over hypotenuse, so that will be 6 over 10. That is also reducible. Right? The 6 and 10 are divisible by 2. So if we divide both of those by 2, we have 3/5. And tangent is the opposite side over the adjacent side, so that will be 8 over 6. Both 8 and 6 are divisible by 2. If we divide those values by 2, we get 4/3. Notice we got the same sine, cosine, and tangent ratios for both triangles. So what does that tell us? The big idea here is that similar triangles have the same trig ratios. And this goes the other way. If two triangles have the same trig ratios, they must be similar. Right? And we know that because their sides are in the same proportion. right, so you should be able to find the sine, cosine, and tangent ratios for any triangle given an angle of reference. We're going to do one more. This one's going to involve a little bit of solving before we can find our trig ratios. So first, and there's going to be a problem just very, very similar to this on the formative. Using the triangle below, what's the value of x and what is tangent b? All right, so notice we have two overlapping triangles. All right, do not compare x with 8 because x is not a side in a triangle, and it is not going to be in the same ratio as the sides 10 and 35. I guarantee you that. There is a theorem that if you have parallel lines, they're going to split the sides proportionately, but that doesn't work if we're dealing with the sides doing the splitting. So 35 and 10 there and 35 intersect that side CB. So they're not going to be in the same proportion as x and 8 are going to be. They will be in the same proportion, however, as the sides. So when you're solving a problem like this, make sure you use sides of similar triangles. So I separated these triangles so you can see the two of them. We have the larger triangle, ACB, and we have the smaller triangle who's missing some letters, probably needs a name. There, now he's got a name, DEB. Oh, by the way, this one is in your notes. It is the last problem after solving triangles, right before trig word problems. And expectation, I would like you to take notes on this problem. And I cut and pasted the problem so I was over on this particular slide, so I would have it for the trig review. And these are two right triangles. So that part there, I don't think copied. That is a right triangle, and this is a right triangle. So these are two right angles. So first of all, we know these triangles to be similar. Triangle ACB is similar to triangle DEB, and we know that using angle triangle similarity postulate. All right, they both have a right angle, so angle C is congruent to angle E. So we didn't look at it and say, hey, that looks like a right angle. That really is a right angle. The markings got erased. And then along with the letters. And secondly, we have angle B is congruent to angle B so this one was given, and this is using the reflexive property. All right, so we know these two triangles are similar. And if triangles are similar, that means their sides are in proportion. So similar triangles have sides that are in proportion. Right, so we could use proportions to solve. Let's match up the corresponding parts. So AC is 35, DE is 10. CB, we add the pieces, is x plus 8, and EB is 8. So that means that 35 is to 10. All right, so we're comparing. Actually, let me write it in words first, just to make sure we're clear. It's been a little while since we've seen similar triangles. So DE is to AC. All right, those sides are in proportion. I've got one triangle in the numerator, one triangle in the denominator. As EB is to CB. All right, so the corresponding sides in the triangle are going to be in proportion to one another. We can replace the names with the values. So DE is 10, AC is 35, EB is 8, and CB is x plus 8. All right, so notice I've matched corresponding sides. So DE here, now color code, DE corresponds with AC, and EB corresponds with CB. Right? All right, so now we could reduce. We cannot cancel the 8s. You can't cancel things that are added. Right? You just can't cancel out an addend from two sets of numbers. Right? They're not. Division's not the inverse of addition, but you can reduce a fraction. So 10 and 35 are both divisible by 5. I could divide that by 5, and I'd have 2 over 7 equals 8 over x plus 8. That's all actually I could do one other reducing if I wanted to. I could reduce the 2 and the 8 and make that 1 and 4. I'll leave it like that just because sometimes students don't reduce in the numerator, and I want us to have some practice with distributing. So here, one thing that is true about proportions is that their cross products are equal. Right? So I can multiply 2 times x plus 8, and that would be equal to 8 times 7. At this point, if you wanted to divide both sides by 2, you could. I think I'll just leave it and solve it the way it is, and then we can reduce afterwards. So 2 times x is 2x, 2 times 8 is 16, 8 times 7 is 56. Subtract 16 from both sides. So 2x equals 40, and then if I divide by 2, x is 20. Right, so that's my missing value. Obviously not drawing a scale. Right, so x is 20. This is a little out of line here. Oops, it's kind of connected that way. So we've done the first thing. Let me just make that just a little bit neater. X is 20. We solved for x. All right? So if x is 20, that means that CB is 28. So now we want to find the tangent ratio for angle B. But which triangle do we use? Do we use this triangle, the big triangle, or do we use this triangle, the little triangle? Let's use them both. Right? So let's find tangent B in the big triangle. Maybe we'll call it by its name, which is triangle ACB. And then let's find tangent in the smaller triangle, which is triangle DEB. Little reminder that tangent is opposite over adjacent, so SOHCAHTOA, right? And so that means let's find the opposite and adjacent in both triangles. So in triangle ACB, the opposite side is 35. That's across the triangle. The adjacent side is 28. So that means that tangent B in the larger triangle would be 35 over 28. Now that's reducible. They're both divisible by 7. And if we divide 35 by 7, we'll get 5. And if we divide 28 by 7, we'll get 4. So there's our tangent ratio for angle B. Let's find the tangent ratio in triangle DEB. All right, so we have angle B marked. Across the triangle is side 10. That's the opposite side. The adjacent is that leg there that's marked with an 8. Right? It's the side that's next to the angle. So that means the tangent ratio for angle B in triangle DEB is going to be opposite, which is 10, over adjacent, which is 8. But hey, those are both divisible by 2. So let's divide those by 2. And notice we get 5/4. course, we get the same answer either way. And why is that true? We get the same answer because these are similar triangles. Of course they're going to have the same trig ratios. The sides are in proportion, right? So it didn't matter which triangle you use to find tangent B, you get the same answer because the triangles are similar, right? So I hope this helps you on the formative. This was my last problem, and so you'll see 5 problems that are very similar to this. Feel free to take notes and use it on the formative. Thanks for watching and have a great day.